going to be talking about three kinds of rocks, the rock cycle. So these are probably things that you might learn in science. So, it may be like stuff you already know. That's good. So this is how it is given in our syllabus. Okay, describe and interpret the rock cycle, state and explain the formation and characteristics of named igneous, sedimentary, and metamorphic rocks. And the further guidance and exemplification is actually giving you specific things to learn. Okay, for example, when you talk about the formation and characteristics of named rocks, should you know all the rocks? No, you just need to know two. Okay, and the examples are granite and basalt. So those two igneous rocks you need to know. Again, sedimentary, 2 or 3. It's better if you know more, that's good, but this is what is really required, or the basic, the bare basic, So questions will be along these lines. So you have to be very, very familiar with the syllabus. Okay, that's like half the journey. Knowing the syllabus, what are the topics I'm going to learn, what are this? Yeah, this is so seriously important. Now, the first thing you have to understand is about the structure of the earth. In this picture, you can see 4 layers. Okay, the outermost layer is the crust. And then comes, as you go inwards, it'll be the mantle. Then you have the outer core, and right in the center of the earth, you have the inner core. Okay, how is it different? What are the specific things that you need to know here? Okay, we will come back to this topic about the structure of the earth in chapter 6. So at that time, I will be going into more detail. Right now, I'm just giving you an idea so that you understand the rest of the topic. So the first thing is you've got the inner core right at the center, which is really hot, but solid metal. It's mainly metals like iron and nickel. These two elements are sort of like compressed and compacted and sort of made into a solid in the heart of the earth, in the center of the earth. And the interesting part is it spins very gradually. It spins. And because of the spinning movement, you have the Earth's gravity. The pulling force, okay, in a way is connected to the spinning of the inner core. And if the inner core stops spinning, we could probably be floating into space. So inner core is solid. It is extremely hot. And it is moving. It's made of metal, and it's sort of spinning gradually. Just outside the inner core, you have the outer core. The only difference is that the outer core is not as solid, it is liquid. Okay, liquid in the sense that it's really thick, gooey, hard material, but it's still not solid. So the state of matter is sort of like, semi-solid, you can call it that way. So that's the outer core. Again, it's made of iron and nickel, and it is not as hot as the inner core. Okay, so it's getting cooler. Yeah. Okay, the mantle is the next layer. Outside the outer core, you have the mantle. The mantle is the widest portion. It's really thick, and this is mainly the molten rock. It's called magma. The material is called magma, but the layer is called mantle. Mantle is the layer. But what is it? What is the mantle made of? It's not iron and nickel. It's a combination of a lot of minerals, okay, elements. Like you may have gold in it. You can have silica. You may have aluminum. Everything we get naturally is basically in the magma, okay, in a gooey form. So it's already in the mantle, yeah, and it's melted. So it's liquidish somewhat. When I say liquid, please don't imagine it as water. It's not as liquid as water. It's really thick, hard jelly-like stuff. Okay, think of it like Play-Doh, which is extremely hot. Again, the density, the thickness of it can change. Sometimes in some places it may be like more liquidish, whereas in other places it may be more thicker. It depends on what mineral is there. Okay. Anyway, but you please imagine in your mind something really hot, and you've seen pictures and videos of lava, volcano erupting and all that. So yeah, so that will help you understand. I'll show you a video of that as well. So the mantle is the second layer from outside. The second layer below the crust. It is where the magma is present in the mantle, And here the magma is actually moving, because it's called convection currents. In chapter 6, I'll be going over this again. So because it's moving, the outer shell also sort of moves. And this is why you have earthquakes and volcanoes and mountain formation and all that. Okay. But right now, just understand that the next layer outside the outer core, the next layer is the mantle. It's made of melted rocks or molten rocks. Melted, molten, same thing. So this molten rocks is called magma, right? And that is the next layer. That's the widest, thickest layer. Okay. And then you have the outermost shell, the outermost covering. The shell of the earth is a very thin layer. When I say thin layer, it's about 10 to 100 kilometers thick. But when you look at the size of the earth, that is like an eggshell. That is really thin. So the crust is where we live on. And today we're going to be talking about rocks and minerals. So the crust is the most important part of it. Okay. Next, we're going to be talking about rocks. Okay. Not the melted rocks, not the magma, but the real rocks, the solid ones. And there are three main types. You have the igneous rocks, the sedimentary rocks, and the metamorphic rocks. Okay. Now, it's very important you memorize these words and you memorize the examples and how it is formed and the specific processes. You need to memorize it, learn it well. Okay. The word igneous it goes with the word fire. So it is formed by fire in the sense of melt. The melted rock has to cool down. So it forms from fire. Okay. So that we will see. It's called igneous rock. Sedimentary. So from that word sedimentary, the word it's got the word sediment in it. So sedimentary is the sediment. And then you have the metamorphic. Metamorphosis in biology, you might have learned it, is when the egg becomes larva, larva becomes pupa, and pupa becomes butterfly. You've learned this, right? So this is change. Metamorphic goes with the word change. So igneous goes with the word fire, sedimentary goes with the word sediment, and metamorphic goes with the word change, metamorphosis. Some change is happening, and so we will learn how that change happens. All right, so first main objective, we're breaking it down into four different objectives. The first one is the formation of igneous rocks. So here you will be able to state and explain the formation and characteristics of igneous rocks. There are two igneous rocks, granite and basalt. So we're going to look at these two rocks. They're both igneous, but we're going to talk about how is it each one formed, what is the difference between them, what are the characteristics, all of these details we need to know. Okay, so we're going to look at that. In this video, I'm just going to be showing you a small part of the video. You can see lava flowing, right? So here you have, this is the lava, not magma, lava. The difference between lava and magma is once the magma comes out of the earth, it releases those trapped gases. So it may have carbon dioxide and sulfur dioxide and nitrogen oxides and all the water vapor and all these trapped gases are released out. And then the lava contains only the liquid rock part, it's the minerals. So that's a slight difference between lava and magma. So it's the same thing. When magma comes outside the earth during such as a volcanic eruption, you have lava. So what you're seeing right now is lava. You can see it is made of, it's gooey. So this is how, if it's like that here, probably the same thing what's happening inside, isn't it? The mantle is also somewhat like this. Okay. It is also sort of moving and all that. Usually when I teach this topic, I talk about, a chicken egg. When you look at the egg, you have the outer shell, isn't it? That outer shell is same as our crust. And you can see right now the magma is, going to cool down. You can see the black thing around it. That black thing is the rock called basalt. So this rock is formed by the cooling and crystallization of the magma. Okay. So that outer shell, the crust, is basically that, cool down rocks. Most of it is mainly igneous. If you look at the crust, most of it is igneous rocks. It's either basalt or granite or some other igneous rocks. There are many, but mainly it is granite or basalt. and it's formed by the cooling of magma. So that's the main thing, yeah. And then you have the other two types, sedimentary and metamorphic rocks as well. Now, you can see that the lava flow has reduced, see? And it's now going to cool down very gradually. It's going to cool down. This may take, depending on how it's cooling. For example, if you spray water on it, it will cool down faster. But if you just let it be as it is, it's going to take time. It's going to cool down much more slowly. Okay, so if the lava flows straight into the ocean or something, yeah, you can see that it will cool down faster. And if it cools faster, you will have small crystals. The crystallization, when it cools down, it forms crystals, right? They are generally small crystals if it is fast cooling. If it is slow cooling, I'm talking about slow in the sense months and years, then the crystals start to grow bigger. And usually this happens inside the earth. Okay, so you can see here a rock formed by fire. This is called igneous rock. And this is a primary rock because it is formed by it's the first formed rock. Primary means one, isn't it? So it's the first formed rock. You call it a primary rock. Okay, sedimentary and metamorphic rocks are secondary rocks. They're not primary rocks, they're secondary rocks, simply because it's not formed first. It's formed once you have an igneous rock. From it, you can have sedimentary, you can have metamorphic. So this one is the first rock. We call it a primary rock. Yeah. Is there any questions? Please feel free to put it into the chat. Okay. Now, there are two types of igneous rocks. One which is formed outside the earth and the other one which is formed inside the earth. When I say inside the earth, I mean the crust. Okay, I'm not talking about the mantle at all. Now I'll be only talking about the crust, the outer shell. So somewhere inside where you see this yellow color, bright yellow, now you have right now, maybe that's magma. But that magma is going to cool down very, very gradually over a long period of time to form igneous, intrusive rock. Okay, now igneous itself, there are two types based on whether it's outside or inside. If it's inside, you call it as an intrusive igneous rock. And the example is granite. Okay, granite is an intrusive igneous rock. Intrusive, the word I means inside, isn't it? Extrusive is the other one, which is external, internal, external. So that's easy to remember. So intrusive means internal. It is formed by the magma cooling down very gradually, forming very large crystals. And you can see those crystals in the granite. Yeah. They are different minerals. That's why they're of different colors and all that. Whereas basalt is by faster cooling. It's on the outside of the earth. So the magma has to literally come out as lava. And then it'll cool down to form these tiny crystals. You see a black rock called basalt. Now, let me ask you a question and you just put it into the chat. Tell me, if you want to get basalt or granite, which rock will it be easier to take? Easier, cheaper, all that. Put it into the chat. Which rock will be easier? Is it basalt or granite? And if you could give a reason, that'll be nice. Basalt, yes, you're right. Basalt is going to be cheaper. Could you give a reason? What makes it cheaper? What makes it easier to take? Yeah, okay, because digging inside the earth is not correct. You don't have to dig deep into the earth. It's right on the surface. Oh, yeah, you got it right. It's easier to collect, yes, less time. Well, not because it's less time taken. No, that doesn't matter at all. I mean, by the way, these rocks are formed like millions of years ago and all that. So even now, when there is a volcanic eruption right now, as we speak, there are volcanic eruptions around the world. So it's always continuously forming. So it's not about the time taken. Extraction is the thing. Well, and that's our next topic. Okay, we'll be learning about mining. So at that time, we will learn this. So it's easy because it's right on the surface. Mining, taking it, collecting it will be easy. So basalt is very cheap rock. It's used for very general stuffs. But granite is a bit more expensive, and so it's got special uses. You can see here a volcano, right? And you can see the ocean floor and all that. So here you have different kinds of rocks. Each color that you see is actually different rocks. Okay, so here you see there is this region, the yellow region over here is called the magma chamber. All right, the magma chamber sometimes have these small extensions, okay, or paths through which the magma flows into smaller spaces and then it cools down. So you have the intrusive igneous rock. But if it comes straight through that hole and comes out of the earth like a big explosion or eruption, we call it as volcanic eruption, you have the lava coming out and it cools outside. Okay, so remember, it's intrusive or granite is always inside the crust, whereas basalt is outside the crust. It's on the ground surface. All right. Now you can see a picture of a volcanic eruption, and you can see how the lava flows, right? And it will, as it flows, it will destroy everything in its path. It can melt things down, burn things away. It's really, really hot, right? So it can cause lots of problems. In chapter 6, we're going to be learning about the impact of volcanic eruptions. How will it kill people? What can, all those details. So we'll just get to that later. This is the extrusive igneous rock called basalt. Yeah. So it is grayish, blackish. Again, it depends on the different minerals. The color may change, but generally the crystals are very tiny, and it's formed by the cooling of lava outside the Earth's surface. This one is again basalt. You can see it doesn't look exactly the same as the other rock, right? So again, tiny crystals, very cheap rock. This is very commonly seen on the Earth's surface. Wherever you go, you may see this rock everywhere. So in some places, you can actually see this kind of vertical joint. Like in this picture, you can see when the magma cooled down, it formed these vertical lines, joint. So this is typical of igneous rocks, particularly on the surface. Okay, so you may have like these kind of lines. Again, crystals are small. This rock is generally darker in color. Okay, and it has a higher density than granite. Okay, it's more dense. You learn it in physics, right? Like, it's the particles are more compacted. So it's going to be a little more heavier. Not much. It's actually 0.4 grams per centimeter cube. So if you have a centimeter cube of granite and you've got a centimeter cube of basalt, basalt will be about 0.4 grams heavier. But when you talk about a big piece of rock, it adds up, isn't it? So when you have a larger volume, obviously it's going to be much more heavier than granite. Okay, and that's because it is compacted. It's these tiny crystals, and it's made of these elements. That's probably why it is more heavier, but just keep that in mind. It is going to be more heavier, high density. And what is it made of? It's mainly silica. Okay, silica. Silica is sand, basically. Okay, so when we talk about sand on the beach, sand crystals, pieces of sand, we are talking about the rock that has broken down. Yeah, so when this rock breaks down into tiny bits and pieces, you have sand. And when sand becomes broken down further, you have silt. And when silt breaks down even further, you have something called clay. So I'm just saying that, you might have heard of sand and silica. You know that glass is made of silica, right? You might have learned this. So silica is basically Si, element Si, silicon dioxides. All of these elements are found inside the basalt. Okay, less than 55% silica. Iron and magnesium minerals are also found here. Okay, in the basalt, and basalt is porous. Porous in the sense that it's got these tiny spaces, and it can absorb water. Not fast, very gradually, but it does. So if you take a basalt rock and you put it in water, it can absorb water into it. And in fact, when we dig a well, inside the earth there is, you dig a well to get water, you're reaching this layer called basalt or granite or some other rock. It has to be porous rock. Granite is not porous. Basalt is porous. So it can contain the water in it, and the water slowly comes, as you take water, it gets collected inside the well. So when you pump water, it'll keep on coming, We will learn this in chapter 4. Okay. So porous rocks, it's got space. Now, the next one is called intrusive igneous rocks. And you can see in this small video clip, you can see how the magma sort of like rises through. You can see that this is during a volcanic eruption or due to, plate changes and all that. It's coming through. It's getting pushed That's because of the pressure, and it's as it rises through, you see that it went into those spaces and cavities and all that, and that's where it's going to cool down gradually, very slowly, forming large crystals. You have granite. But if it's coming right on the surface, you have basalt. Okay, so intrusive igneous rocks is by the slow cooling of magma inside the crust producing granite, whereas extrusive is when it comes outside the earth during a volcanic eruption and it cools down really quickly, forming these smaller crystals, and then it will break down over time. This is called weathering. Weathering is the process of breaking down of rocks, over time. So that can happen. In the book, they have also given something similar to this picture. You can see there are 2-3 words that they've mentioned, so I think it's important. So far, and by the way, this is important information. You know that in 2019, the syllabus was changed. Until 2018, the syllabus had some more topics and all that, but now it has changed a bit. So some new things have been added in and some old things have been taken away. So you may not see any of this specific questions for this one I'm talking about right now in past paper questions, because it's sort of a new topic. So when it's a new topic, I'll tell you, all right? So here we have vertical and horizontal way in which it goes. See, if the lava sort of comes, straight up, it's got this vertical way of poking through the different layers. You call it as a dike, D-I-K-E. Okay. The other one, when it goes sideways, it's called sill, S-I-L-L. Okay. So dikes are when the magma pushes through in a vertical way through the different layers of rock, and it creates this. And then later on, that magma may cool down to form granite. So granite may be found in these dikes, or it may be found in this sill. The other words are not really needed. Okay, so these are the 2 things. And batholith is actually deep down below. If the same rock is found deeper below in a bigger way, you call it as a batholith. Okay, so you see the dike over here, you see the sill sideways horizontally, and then the batholith deep beneath it. Now, probably this is the magma chamber, and you can see the vent. Vent is the gap through which the lava comes out. So, and then it forms this volcanic cone over there. So just keep that in mind. So extrusive rocks are found on the surface, whereas intrusive rocks are deeper inside. So, you have to do deeper mining, underground mining for intrusive. See the magma chamber, magma reservoir. Then you have the magma, which is a molten rock below the Earth's surface. The lava is magma that has been ejected or coming out. Here, the lava is coming through a fissure. Fissure is like a crack in the ground, not a hole in the ground, but a crack. In chapter 6, I'll be teaching you about this later. So, and then you have the dike and the sill and the batholith. Okay, these are the basic things shown here. Sedimentary rocks. By the way, what you see in dark color is all igneous rocks, but the lighter colored rocks are sedimentary rocks. And it's got this horizontal layering sort of thing. I'll tell you why it is, but just know that in this picture, you see not only igneous rocks, you also see sedimentary rocks. And the igneous rocks are the darker colors that you see. Even the volcano, that cone-like thing, the volcano itself is made of basalt. So that is all igneous, whereas the lighter grayish color, that's the sedimentary rocks. I hope everyone's following with me. Okay, what is a dike? So when you have the magma pushing through these different layers of rock upwards, vertically, okay, vertical, you will see dikes. It's called as dike. They have just put a name for it, okay? It's nothing different. Sills and dikes, the same thing. It's just that the magma has pushed vertically and it has created that extrusion, through the different layers. But if it has gone sideways, you have something called sill, S-I-L-L. The intrusive igneous rock granite is found inside the dike, it's found in the sill, and it's found in the batholith. If you want a specific definition, I'll be putting it into the notes. Okay, so far they haven't asked any of this. Yeah, but definitely they'll ask about granite and basalt and things like that. But this is something not very common. You won't see it in past papers. All right, the next thing you can see here is granite. Okay, it is formed by the magma cooling slowly inside the earth, and you can see the big crystals. Each crystal is a different mineral, and they all have names. We don't need to know. but that's why they have different colors. You have the red color, which is one mineral, then you have the gray and the white and all of these different things. Now, you can see here a place where rocks are being cut out. Can you see those two guys standing over there? So this is like a mountain, and they are digging into the mountain. You can see they are cutting it layer by layer. That's why it's got this, box-like look. It's a real picture, and obviously that is a granite quarry. Quarry. A quarry is a place where rocks are mined. Okay, so this is a rock quarry. And you can see the people are standing there and using machines for drilling and cutting and all that. It's a tough job, and that's what makes granite more expensive, because it's difficult to take. The crystals are large crystals, usually a little paler color. It's not very dark, blackish or brownish. Again, granite can be of different colors. It could be gray granite. You can have sort of blackish color, green granite, red granite. You can have different colors naturally. They are all natural because of natural minerals inside that, okay, depending on where you get it. So based on that, the price will differ, okay. So it's generally, compared to other rocks, a little lighter in color. It has low density. Compared to basalt, it is lightweight. Don't imagine that it's very light rock, it's heavy, but compared to basalt, it is a bit more lighter, okay. The percentage of silica is more. Okay, in granite, silica is more than 65%, whereas in basalt it was like 55. So this is more than 65, so it's got more silica content, and it's also got the mica and feldspar. What are these? These are all minerals. Silica is a mineral, mica is a mineral, feldspar is another mineral. Granite is non-porous. Okay, now this is very important. If a rock is non-porous, it cannot absorb water, and if it cannot absorb water, imagine a place with this granite, and it's been raining heavily. So if you after the rains, the water will soak into the soil, but because the rock is non-porous, it cannot absorb any water. It won't go down. So you will have a flood. There is a chance of floods. So depending on the nature of rock, whether it's porous or non-porous, there are problems and benefits. One thing is, in granite, you will not find water. So if you're digging for water, you're making a well, and you're getting only into granite, forget it. There's no water in the well. If you need water, you need to dig into a rock which is porous, like sandstone or limestone or basalt. Okay, so it's very important. Even basalt is not that porous compared to sedimentary rocks. Igneous rocks are not that porous. So granite is basically, even though I say non-porous, they do have pores, but they're so small and they're so arranged in a way that water can't go in. So you can basically call it as non-porous. Okay. Again, in the notes, you will see this table. It's a comparison between basalt and granite, how it is formed and the characteristics. It's basically what I just taught you. There's nothing different. Okay. Now, granite is plutonic intrusive rocks cooled deep below the surface in batholiths. Batholith was that big, magma chamber like thing, So inside that, somewhere deep inside the earth, you have slow cooling. Yeah. And that's how granite is formed. Whereas basalt is volcanic. Plutonic means inside. It's not volcanic, but it's produced by the heat, and it has these characteristics. All right. What is basalt used for? The uses of basalt. Basalt is used for general uses, not anything particular, but it can be used to make sculptures. Like this sculpture is made of basalt. Made from basalt, and they have, I don't know, polished it maybe, I don't know, it looks nice anyway. Usually this rock basalt is crushed into small pieces of rock called gravel. Now gravel is needed in road construction. So when you're making a road, you mix bitumen, and you mix the gravel and you mix some sand into it. So sand, gravel, and instead of cement, we put tar or bitumen, the sticky black thing. Yeah, that's how they make the roads. Road construction is generally in that way. So gravel is important for that. Here, this is a picture of how do I say it? It's a garden, in front of a house. Not a garden, this backyard. So they have put these small stones everywhere. These stones are gravel. It looks okay, and it prevents the grass from growing through it, so it keeps that place neat all the time. If you don't put the gravel, maybe the plants will grow, weeds will grow, so that's how they've used gravel. Now basalt indirectly can be used. Okay, now we don't use it, but it turns into volcanic soil. Now this is again very important. In chapter 3, when we learn about farming and all that, this part will be important. Basalt contains phosphorus and potassium and things like that into it. So when it breaks down, that process is called weathering. When rocks break down into tiny pieces, we call it weathering. So that weathering process will produce tiny bits of sand, silt, and clay. And this is what soil is. So soil is just rock which has broken down over time. Soil is not only broken down bits of rock. Soil contains air, water, it contains living things, it contains a lot of decomposed material, right? So we will learn about soil structure and all that later. So this is volcanic soil which is produced from the basalt by the weathering process, by the breaking down of those rocks into fine pieces. So you have the volcanic soil. Okay, that's a use for us because soil is so important. We grow our food, we grow our plants because of the soil. So having volcanic soil encourages farming. So near volcanoes, that's why you will see lots of farming going on, because the soil is really fertile, very nutritious for plants. So they grow really well. Okay, I hope everything is clear. If you have any doubts, please ask. Okay, so this is the basic uses of basalt. Next, granite. Of course, there are many uses for basalt. For example, basalt can be used as tombstone. Because it's a cheap rock, you can cut it, you can smoothen it and shape it. You can use it as not a sculpture, but you can use it as a tombstone where people are buried and they write everything down. Now, this one is granite, so it's used for that purpose. It's also it's a beautiful rock. When you polish it, it looks nice with those dots in it. Different colors again. You can see in this picture the red, the sort of yellowish brown color, the grayish black color, all of that. So different dots and everything. It looks nice when it's polished. By the way, it's polished. That's why it looks like this. If you take just a piece of granite, it has nothing special about it. It's just like an ordinary rock. But when you polish it, you will see it looks really beautiful. So it's used on countertops, like for example in the kitchen countertops. You may have it in your flat. They use it on the floors as flooring tile. They sometimes use it on the walls. So building construction, yeah. It can be used as a furniture. For example, in this one you can see a table and a sitting place. So it's a hard rock, so you can use it in so many different ways, making sculptures and things like that. Okay, so we've learned just now about the formation of igneous rocks. We've learned about the characteristics of igneous rocks. Okay, we've learned about basalt and granite. We know what is the difference between them, how is it formed, what are the specific composition of it, and things like that. Okay, I hope there's no doubts, though no questions.